Hello guys, welcome to our YouTube channel High Speed Board Design. Today we are going to discuss about how to reduce crosstalk. In our earlier lectures we have already discussed the type of crosstalks. One is NEXT, that is near end crosstalk, and the other is FEXT, that is far end crosstalk. I have already created a video on describing both the type of crosstalk and how these crosstalks are produced. You can always check that in my YouTube channel. I will pin the video here for your convenience in the tab. In today's lecture, we are going to discuss about how to reduce the crosstalk. If we are getting a crosstalk in our design, and whenever we are simulating the design and we are getting a higher value of crosstalk, then how we are going to reduce that crosstalk? Being a signal integrity engineer, what are the guidelines that need to be followed in order to reduce the crosstalk? Today we are going to discuss about those guidelines. So today we are going to teach different ways how to reduce the crosstalk in the design. First of them is increasing the space between the traces. So for example, if you are having two traces, one of them is aggressor and the other one is victim, and there is 1 mm of distance between both the traces, or we call it as spacing between both the traces, and you are getting a crosstalk here. So you are getting the near end as well as far end crosstalk here. So in order to reduce this crosstalk, the first method is by increasing this spacing. So this spacing, if you increase it to 2 mm or 3 mm, then the values for this crosstalk will reduce, as you can see here. So the first way to reduce the crosstalk is by increasing the spacing between the traces. If you increase the spacing between the aggressor as well as the victim trace, the crosstalk will be reduced. Let us discuss about the second way how to reduce the crosstalk. So the second way says move critical signals to separate routing layers. So the main principle behind this option is, so if you're having a stack up with multiple layer, for example, layer 1, layer 2, layer 3, layer 4, and layer 5. And in particular, layer 3, you are seeing more crosstalk. In particular, layer 3, you are seeing more crosstalk, and there are multiple signals there. For example, A1, A2, B1, B2. So there are multiple signals which are available there in that particular layer. And if your critical signal is A1 and A2, which are the victims here, so in order to reduce the crosstalk, try to put them in some different layer, maybe in layer 2 or in layer 1. So this will definitely reduce the crosstalk in the particular important layer, that is A1 and A2 in this case. So the third way, in order to reduce the crosstalk, ensure that the signal reference plane is also connected to the IO driver. So what is the meaning of this option? So in this option, if you have an IO driver, we call it as a transmitter, positive and negative. If you are having a transmitter and your signal is being connected to a particular net, let it be a victim net. So whenever you are connecting your signal TX to the victim, in that same manner, you need to connect your ground pin also. So there is always a ground pin. So if you check the transmitter, there are signal pins. There should be a VSS or VDD, and there will be ground pins. So the ground pin should also be connected to the reference of this victim. So the ground pin of transmitter as well as receiver should be connected to a single ground plane. A same ground plane should be there. So this will definitely reduce the risk of getting crosstalk in between, and there will be reference plate that will help you to reduce the crosstalk. Let us move on to the next option. So whenever you want to reduce crosstalk, all you need to do is you need to add guard traces that should be properly grounded. Let me explain you how this is done. For example, if your trace is like this, it is in a serpentine manner. This is your signal, and you are seeing high crosstalk in this. So you are getting high crosstalk next and fifth. So in order to reduce the crosstalk, all you need to do is you need to add guard traces like this, as you can see in the diagram. So these are the guard traces. Guard traces can be a reference plane, a GND. So you need to guard so that all the crosstalk that will be created in this serpentine state will always be observed by these reference planes. So this is also reference, this is also reference. I hope this is clear. So the next way to reduce the crosstalk is by minimizing the coupling length. Let me explain you this part, how we are going to minimize the coupling length. For example, let us take first scenario A and second scenario B. So in this scenario A, we are having two traces. One is the aggressor, other is the victim, and both of them are running along with 1 mm of spacing, as well as they are running along till 10 mm. Okay, 10 mm is the distance, is the length to which these traces are already coupled. So the coupling length is 10 mm. In case 2, in case B, if we see the trace spacing is 1 mm, which is similar in both the cases. But if we talk about the coupling length, it is just 5 mm. So in that case, once the coupling length reduces, the crosstalk will also reduce. So crosstalk is directly proportional to coupling length. Coupling length. So if the coupling length is high, the crosstalk will always be high. And if you want to reduce the crosstalk in your design, all you need to do is you need to reduce the coupling length. Thank you for watching this short tutorial. Please like this video and comment down. If you have any issue, you just comment down to us. Please subscribe to our YouTube channel. As I can see, most of you watches my video but don't subscribe to the channel. Please subscribe to the YouTube channel, and if you have any doubt, you can always comment down below and I'll be happy to help you with that. Thank you and have a nice day.